Hello, welcome back to BLENDERSUSHI live noding. Last time we were up to here, we basically kind of able to source like a pixel art here, 64 by 64 pixel, and I kind of wondering if we actually try to use the data here, and it's kind of what if we actually kind of repeat the data and then try to make this artwork a little bit bigger. I'm pretty sure that we can do it using the nodes. So I try if I use like list repeater and then maybe repeat the number 4 times and then it maybe increase the number of pixel 128 by 128. Apparently we are getting this. So I kind of wonder. Okay, that's strange. After kind of playing around with it, I realized that if we are actually repeating the list, it's actually making the data goes like this, like upward. Well, I thought that's kind of interesting, so I just want to share that. But there is also another things that we can do here. What if we pipe this image right here into a grid? So will that be easier to kind of scale the image that way? So maybe we can do that. So I'll create a plane and then kind of create a B mesh here. I'm gonna switch to cycles because we're gonna work in cycles. And the plane I'm gonna make it 64 by 64 vertices, or 64 by 64 points, and plug in the vertices to this guy and the polygon face to that guy, and we have this this mesh, and we just need to give it a materials and also give it a vertex color, and hopefully simply by piping this guy into the color we should get our image. Okay, it's giving me an error, so we shouldn't use the list repeater, but just plug that in and switch to material, and there you go, we get the pitch image. Although you might realize that this is actually assigning the color into each and every vertices, so yeah, be careful with that, because what we really want is 64 color assigned into actually 64 by 64 color, because it's how the pixel is originated. It's the dimension is 64 by 64 pixel, but here we have 64 by 64 points, but the face itself is not 64. So that's very important. If we switch this to face, however, we get our pixel, but then I think the number doesn't quite match it. So if I'm increasing the number of pixel, then we get the image, but then I don't know, we get the image kind of sideways. So that's kind of interesting, I think. Well, I guess it doesn't matter for now. We can just simply rotate it. I think it's kind of important how the pixel is actually being read. Maybe it's from the bottom left to bottom right, and with a plane mesh, maybe it's being generated in a different kind of directions. Okay, I'm just gonna rotate this guy 90 degrees. So okay, we get that. Apparently this one is actually the other way around, so well, that's interesting. Anyway, just rotate it 180, so we get our image back. And this guy is actually unlimited in resolutions. Unlimited, what I mean, it's not like we can scale up the pixel, but this is like you know, you can scale it really big and render it like really big. Doesn't matter. Okay, cool. So we managed to get our pixel image into a single plane. as a vertex, as actually as a assigning it into a polygon face. All right. So what else can we do here? Maybe we want to make a couple of variations of the same image. So instead of having just one, maybe we want to see a couple of variations all at the same time. We can actually do that simply by using the matrix for instancing. So we're gonna make like a duplication here. So vertices goes into that guy and maybe spread it. Okay, now we have that. Okay, that's pretty good. But we are seeing the same this vector noise being applied. So if we use like a range integer, we should be able to see variations here. Let's make it how many count? 4. 1, 2, 3, 4. Okay. Give it a count of 4. Alright, so we get that working. Actually, instead of image of Peach, maybe we can try other image. Let's try open Mario Luigi. So I have this very low resolutions Mario and Luigi image. Let's use this one, Mario Luigi plus .jpg and update it. Okay, that's a bit weird, but it's okay. And let's make this a little bit more. 4x4 or 5x5s. We have 25 copies of the plane, and each one of them get a different color. But I think I like it. The process is still pretty fast. And for the number of variations here, the count, maybe I'll just use list length and kind of get the total number of the points. Plug this guy in there and then plug this into the count. Oh. So it's doing some thinking. Okay, cool. So there you go. That's our result. And back to previous. Let's see. So no matter how many copies we have, it will generate like a different random variations for each one of the image. So I guess that's kind of nice. A little bit like modern art, but I know it's kind of interesting. I think 40 variations should be nice. They all look slightly inverted. Maybe because I'm only using a single color. Vector fractal, vector noise, color out. Actually, I'm using all the 3 colors. If I cut the Z and the Y, I tried this before, and using less color actually making the image slightly better looking. So instead of using the RGB and then kind of passing it into the vector noise, single color sometimes give you like just a nice dual tone. Okay, so we have this random modern art. We can of course randomize the seed by changing this value, and also instead of using Voronoi, I think this is Voronoi F4, this is Voronoi F3. Okay, Voronoi F4 usually give a nicer color, more pastel like, and standard Perlin is actually a bit dark. New Perlin also kind of dark. Maybe cell noise is more interesting. It has standard Perlin and then cell noise. Yeah, very hard contrast image. But this is I think, yeah, that's what I say, it's like modern art. Yeah, okay, cool. I think we can keep going with this, or I think maybe it's a good idea just to play around with the color. But here, since we actually kind of separating all the pixel, and we're able to do that, and really what you can do here with the pixel is totally like a beyond the scope. I don't know, you can perhaps like sort the pixel by its hue or by its value. You can do like pixel sorting. You can do like all kind of algorithm, like a filter algorithm for the color. But remember, you're gonna be dealing with RGB color, so it's 4 channel. um, I don't know, it might be interesting at some point. I'll take a look at some example, maybe even using the one of Python module to deal with image and then kind of just piping the color. I think that's gonna be interesting. So yeah, this is another quick look at kind of image processing, and at this stage actually we don't need to use the texture viewer, but texture viewer is really handy to quickly pipe in the data here and then have a look at this, and then if you're happy, you can easily export it out. With this guy, you kind of need to render it out. With a texture viewer, you just quickly export it, like this one, Mario Luigi, save, and we should have it. Okay, there you go. It was still calculating. There you go. That's just like a photo studio, photo booth. You get 4 photos at once, so you get this. Anyway, very interesting modern art. Yeah, anyway, thanks again for tuning into this video. If you have any question, feedback, just let me know, and I guess I'll see you in the next video. Thank you.